So I like this next example because it's relating back to science, and I love anytime we can relate back to science in math because they go hand in hand and it's a nice application of processes and problems. So we have the formula that we know for finding Fahrenheit, which is going to be that Fahrenheit is equal to 9/5 of Celsius plus the 32 degrees. So basically, if we know the temperature in Celsius, we're able to find it in degrees in Fahrenheit using this equation. So I need you to go ahead and complete this table with the temperatures in degree in Fahrenheit or Celsius, depending on which one it is. So go ahead and take a moment to figure out what each of those values are, and you may pause the video for that. So you should have found the remaining values for Celsius, and so the first one that's missing is the one that correlates with 104 degrees Fahrenheit, and so that would be 40. And then the other one is correlates with the 50 degrees Fahrenheit, so that would be 10. And then the 62 and 6/10, which would be 17. And then our remaining values would then be 32, 212, and 77. So again, this is the equation that we can use to represent that function. So what you need to do is write an equation that represents the inverse function. So essentially, you are now stating, hey, if I'm being given the Fahrenheit, can I find the Celsius? And so you need to make the equation be equivalent to the Celsius instead of being equivalent to the Fahrenheit. So pause the video to take a moment to do that. Remember, use inverse operations and properties of equality to do that. So after manipulating this equation, you should have basically subtracted the 32 from each side of the equation, so that gives you the F minus 32. Is going to be equal to the 9/5 C. And then we still need to get rid of this 9/5 part that is the coefficient for the variable. And so we need to use the multiplicative inverse of 5/9 on each side of the equation. So we're going to multiply each side by 5/9. And so now we have 5/9 being multiplied by the Fahrenheit temperature minus 32 degrees is equal to C. And that is the neatest equation for that purpose. You can have some reasoning here that would list why you think it's something that you have that may be different, but it needs to be equivalent to this in some form or fashion. So if you took the 5 and multiplied it through and then all of them being divided by the 9, that would be equivalent, but you might want to include your reasoning for that. So we now have this equation where R is equal to 9/5 of C plus 273.15, which is defining the temperature in degrees in Rankine as a function of the temperature of degrees in Celsius. So if you have this equation, you are going to show that this defines the inverse of that function. So go ahead and write the equation that would do the inverse of the one that has been given, I think is what this is asking.